Hello, class. This will be the last of section 3.1. And what we're going to talk about now is what's called the difference quotient. And if you've taken algebra before, or definitely taken calculus, you've definitely seen this. And it's kind of strange. And the reason why it's strange is we introduced this kind of weird equation. And I do want to make sure that you understand that there is a little method to the madness because this is part of the definition of the first derivative. So for those of you going into calculus, you will see this again. And it's the definition of the first derivative. If I put the limit as h goes to 0, that is the definition of a first derivative in calculus. And so my job as the college algebra teacher here is to prepare you for calculus. And so I definitely feel like it's necessary to introduce this. I will tell you right now that there'll be one of these questions on your first exam to evaluate the difference quotient. So you'll see that in the math world, this little equation is pretty important. So how do we do that? Well, I'm going to show you two equations and go through two examples. There are tons of different equations. Some of them get reasonably complicated. So what we're going to focus on in this class is I would consider the more simpler ones. And I will upload some solutions of more complicated ones, but you'll see when you get to your homework, I haven't given you real complicated ones to solve. And for those of you heading over to calculus, you'll probably get some of those when you get there. So let's start with, hopefully, this would be the most simplest. If we take f of x equals 3x minus 5. And so I'm going to show you two ways to do this. The way, and what ends up happening every time I teach algebra is half the class likes one way and half the class likes the other. So that's cool. Pick your poison with regard to that. The first way, and if the equation's complicated, I think this is the harder of the two ways. Just kind of plug everything in and see what we get, right? So with this x plus h here, wherever you see x, you plug in x plus h. So that first one would be 3 over x plus h, right? And then we have the minus 5. So that is f of x plus h. Then we subtract. We actually just plug x in for x, so we just subtract the equation. And then we divide everything by h. So now we got to do a bunch of algebra on it. First thing you want to do is distribute. So you have 3x plus 3h, right? Minus 5. And then you have minus a minus 3x, so we distribute that. And then minus and a minus 5 gives us a plus 5. And then we divide by h. And so the next strategy is combine like terms. And you could see that this 3x and this minus 3x we can combine, and you can see they cancel each other, right? Because they're opposites. So that will go to 0. And you could see the 5 and the minus 5 we can combine. And so that'll go to 0 as well. So we're left with 3h divided by h. And you can see the h's cancel. And so this ends up being 3. So with regards to this, what is 3 in the linear equation? It's the slope, right? And so the idea is that when you do the first derivative, one of the things that it'll calculate for you is the instantaneous slope at any point of the x value. One of the reasons why you can't take a derivative of an equation that's not a function is that we don't want an instantaneous slope to be infinity. And that's what we're trying to avoid with regards to that. And a straight line, right? A linear equation, the slope is constant throughout. So no matter what value of x you plug in, at that particular point, the slope will always be 3. Unfortunately, that's the only equation that works with. All the other ones get more complicated. So let me show you one more. And you'll see you'll have, I think there's a few of these to practice on my math lab. And so this would be an example of a complicated one that I would give you. And I will upload this presentation and you'll see even more complicated ones that you won't be responsible for, like equations with square roots or equations where the x is in the denominator. That even gets more complicated. And we'll work through some of those maybe a little bit later. If not, you will definitely get it in calculus. So let me show you the other way of doing this, which I find to be a little bit better because it kind of organizes it. Because if you tried to write this out in one big equation, it would be really long in the numerator. So let's take it in 4 steps. Step 1 is just calculate part of the numerator, x plus h. So let's do that here. It's 2. And then we plug in x plus h squared minus 3 x plus h. And you remember from the last lecture, this is x plus h squared. And so when you multiply that together, it would be x squared plus 2xh plus h squared. And then we distribute the minus 3, we would get minus 3x and minus 3h. And then the last step is distribute the 2. So we have 2x squared plus 4xh plus 2h squared minus 3x minus 3h. See what I mean about a lot of terms? So that's step number 1. Step number 2 is find minus f of x. So what is that? Well, remember that we are going to change the sign of each one of those terms in the equation. So this would be minus 2x squared plus 3x, sorry about that. As you can see, minus and a minus gives us a plus. So the next one is add number 1 and number 2. So now we're finishing the numerator here. And so we add these 2 together. And so basically we're looking for like terms, right? So you could see this term here and this term here are like terms. So when we add them together, what happens? They end up canceling because they're negatives of one another. And then 3x and minus 3x here are 2 terms that you can combine. And again, when you add those together, they would cancel. And so what would be left is plus 4xh plus 2h squared minus 3h. And the last step is to add that denominator in there, and so you divide by h. So when you do that, the way I like to do it is take each term and put h underneath. So it would look like this. Because then it's easier not to make a mistake. And so when you look at it that way, this h and this h goes away. So this h only gets rid of one of the h's on the top of 2h squared. So we still have 2h on the top there. And this h and this h goes away. And so you'll see that when you do all these problems, all the h's in the denominator will cancel out. And so what you end up with is 4x plus 2h minus 3. So that would be the answer of the difference quotient. And so to finish this, if we were in calculus, the question would be, what would be the first derivative? Well, you would take the limit as h goes to 0, and you will learn limits in calculus. And basically, you just plug in 0 in for h, and you would end up with 4x minus 3. So for any value of x, if you plug it into the first derivative, you would get what we call the instantaneous slope at any given point on that graph. So with that, that's an introduction of the difference quotient. And there are a few of these in your My Math Lab homework. So hopefully this lecture will help you get that started.